Welcome again to Astronomy Daily. Thank you for joining us. If you haven't already, head over to the Facebook page of Space Nuts. That's the Space Nuts podcast group, and join up if you haven't already. I also want to just take a moment to commend Benjamin Burr for placing a wonderful photograph of Jupiter up recently. I have looked at that with great admiration. Well done, Benjamin. Everybody, go and have a look. It's fantastic. And also, I want to thank Zoran for posting a fantastic image of the Crab Nebula, which has been filtered with that 3D filter thing. It really does make you feel as if you're zooming through space at 1,000,000 miles an hour. Fantastic stuff. Check out the Facebook page for the Space Nuts podcast group. That's where we gather. That's where we have fun. And let's get on with the show.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.
And watching over my shoulder to make sure I don't press any of the wrong buttons is my good friend and confidant and intrepid AI reporter, Halley. How are you today, Halley?
Oh, I'm great, Steve. And you don't have to worry about those buttons and controls.
Yes, some of them are a bit complicated. I thought they might interfere with the broadcast.
Oh, no. No, they are for the cooktop and the sandwich maker.
Oh, well, I feel so much better now. Thank you, Halley. How about some headlines?
Okay, here we go. Carolyn Ernst, a planetary scientist at the Johns Hopkins University Applied Physics Laboratory and instrument scientist for DART's SOL instrument, is examining the early results of the impact of the NASA's Double Asteroid Redirection Test, DART, spacecraft which slammed into a small asteroid called Dimorphos on September 26 to test a potential technique to protect Earth, should we find ourselves on a collision course with a large space rock. One characteristic of Dimorphos jumped out as soon as scientists saw DART's final few images before impact. Its rocky surface strewn with boulders, dust and pebbles. Spacecraft have seen this kind of surface before. Japan's Hayabusa 2 mission to Ryugu and NASA's OSIRIS-RX mission to Bennu both found themselves exploring agglomerations of rock, worlds that scientists call rubble pile asteroids. Ernst said because it looks so rubbly and because of what we know of those other asteroids, she thinks a lot of people imagine that it is sort of a rubble pile or kind of a loosely held together collection of rocks. That said, DART didn't reveal the innards of Dimorphos, so the rubble pile appearance may not hold up. As yet, there isn't a way of measuring the insides of Dimorphos. Ernst postulated that it could be made of larger objects with smaller stuff on top. But it could be rubble all the way down. There's no way to know right now. In June, NASA announced that it had commissioned a panel to investigate UFOs, or, as they have recently been rebranded, Unidentified Aerial Phenomena, UAP. The independent study will begin in the fall, cost less than $100,000 and will begin its work on October 24, a NASA spokesperson said. The study doesn't aim to be the last word on UFOs. It will look at previously collected unclassified UAP observations focusing on how they could be better organized and analyzed in the future to shed more light on the subject. It had already been made known that the study team will be chaired by astrophysicist David Spergel, president of the Simons Foundation, and that the NASA official orchestrating the effort is Daniel Evans, the Assistant Deputy Associate Administrator for Research at the SMD. The team will include former NASA astronaut Scott Kelly, Associate Professor of Computational and Data Science at George Mason University Anna Maria Berea and Research Affiliate with the SETI Institute in Mountain View, California, David Grinspoon, who is also a senior scientist at the Planetary Science Institute in Tucson, Arizona, and a frequent advisor to NASA on space exploration, but there are a host of notable others included, and this recent update revealed the full team. There will be 16 investigators from a variety of fields from astronomy to oceanography to computer science and journalism. The team's findings will be released to the public in mid-2023, when the study wraps up. And looking back in history, Steve, this month in 1946, a V-2 rocket captured the first ever photo of Earth from space. While the grainy black and white images it captured might not look like much today, they were a huge deal at the time, because no one had ever seen Earth from space before. You can imagine the excitement at the time, to be the first to see. The V-2 rocket launched from the White Sands Missile Range in New Mexico. It carried a 35mm motion picture camera that captured a new frame every second and a half. The rocket soared to an altitude of about 65 miles before falling back to Earth. Try and get a cell phone to survive a fall from your pocket, Steve. How about that? But that's all I have for now.
Oh, too right, Halley. Our cell phones should be made of the same stuff our space probes are made of. Now, after overcoming engine troubles, fuel line leaks and a major hurricane, NASA says it's ready for the third launch attempt of its Artemis 1 moon mission. Liftoff has been scheduled for no earlier than 12:07 a.m. Eastern Standard Time on November 14, to be exact. Backup launch dates for the mission include Wednesday, 16 November, beginning at 1:04 a.m. Eastern Standard Time, and Saturday, November 19, beginning at 1:45 a.m. according to NASA. An uncrewed test flight of NASA's Space Launch System (SLS) rocket and Orion spacecraft Artemis 1 will serve as a shakedown for flight systems and an opportunity to run experiments as Orion flies around the moon and back to Earth. A launch date on 14th November would result in a 25.5-day long mission, with Orion splashing down in the Pacific Ocean on Friday, December 9. The SLS rocket and Orion have been stored in NASA's rocket hangar at Florida's Kennedy Space Center, the Vehicle Assembly Building, since September 26, when the space agency rolled the rocket back from the launch pad to protect it against potential damage from Hurricane Ian. The hurricane weakened to a tropical storm before reaching Kennedy Space Center, and NASA indicates very little maintenance work will be needed to get the big rocket ready for the launch pad once again. The space agency currently plans to roll SLS and Orion back to the Launch Complex 39B on Friday, November 4. NASA's first attempt to launch Artemis 1 mission on August 29, but scrubbed that launch after discovering problems in the cooling one of the big rocket engines to the appropriate temperature for launch, a process known as thermal conditioning. The space agency has since resolved it to begin that part of the launch process sooner to give all four of the main stage RS-25 engines, the same engines used on the space shuttle, a chance to condition properly. NASA's second launch attempt on September 3 was scrubbed due to leaking liquid hydrogen at the connection between the line pumping fuel from the ground to the rocket fuel tank. The space agency made repairs and adjustments to its pre-launch procedures, and they conducted a test on 21 September to show the big rocket could no longer leak hydrogen during fueling. But any shot at another launch attempt that month was blown away by the impending arrival of the hurricane. And let's not forget that little fire in the vehicle assembly building. Thankfully, no damage there. If there's a successful launch in November, Artemis 1 mission will lead to Artemis 2, scheduled for spring in 2024, which will see 4 astronauts fly a similar flight path to around the moon and back. If all goes well with 2, Artemis 3 will launch sometime in 2025. The Artemis 3 mission aims to put 2 human astronauts on the surface of the lunar South Pole, the first human boots on lunar regolith since Apollo 17 astronauts returned home in 1972.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
Now, one of the most bizarre phenomena in our solar system is the strange way that Uranus spins on its side. That's a puzzle because all the other planets spin upright. Well, what could have happened to make Uranus so different, particularly from its neighbour Neptune, which formed at roughly the same time in a similar circumstance? The conventional thinking holds that soon after the solar system formed, Uranus was knocked on its side by a series of collisions with some numerous planetesimals that swept through the region at the time. And the problem with that thinking is that it doesn't seem to have suffered too much damage. Now we get a potential answer thanks to the work of Mélanie Sellenfest and colleagues at the Paris Observatory in France, who think that Uranus could have become tilted on its side in another way. And it's very interesting. They say that tilting can be explained if Uranus once had a large ancient satellite whose orbit interacted gravitationally with the planet's own rotation in a way that slowly flipped it on its side. The team simulated the process with Uranus to determine the conditions under which this could have occurred. It turns out that a satellite just 1,000th the mass of Uranus could have tilted the planet as it migrated away from over a distance of about 10 times the radius of the planet. Salenfest and co. say to achieve the tilting in less than the age of the solar system, the mean drift rate of the satellite must be comparable to the moon's current orbital expansion. There's your equation. One thing that could help throw more light on the scenario is a better understanding of the migration of Uranus' satellites today, as well as their other properties. For Saturn and Jupiter, much of this detail had to wait for the visit of orbiting spacecraft such as Galileo, Juno, and Cassini. Just one spacecraft has made the lonely journey to Uranus. Voyager 2 swept past in January 1986 on its way out of the solar system, and although various space agencies have planned to send another orbiter, to date, no mission has been approved. And here's one I missed, but I can't help but mention. In an unprecedented event, Brian May and David Eicher launched their latest work recently, a revolutionary 3D book, Cosmic Clouds 3D. They shared the launch along with creative collaborator and master astro imager J.P. Mezzavano. Cosmic Clouds 3D is the first book ever to represent 3D stereoscopic images of nebulae, the clouds of gas that inhabit our galaxy. These sites are the birthplaces of stars, but also mark their glowing remnants of their demise. The book was born out of the collaboration of Brian May and Eicher, who achieved success with Mission Moon 3D 2 years ago, and now the team driven by Brian May, who is an astrophysicist and also the celebrated founding member of rock group Queen, turned their attention to the faraway universe. They've hooked up with the accomplished first-class finished astrophotographer Mezzavano, who has meticulously created scientifically analysed images showing the components of numerous star clouds in 3 dimensions, made by accurately simulating stereo pairs of objects, well-known targets like the Orion Nebula, Rosette Nebula, the Veil Nebula, and countless others included in this amazing, groundbreaking book. May has been enamoured with stereo imaging, seeing the world in 3D since his childhood, and the book launch hosted at the Science Museum in London was freely open to the public and streamed worldwide. Brian May described stereo imaging and the background of the book, and Eicher, the editor-in-chief of Astronomy magazine and the author of 25 books, spoke of the physics of these star clouds and what they mean in astronomical terms, and Mezzavano detailed the creative methodologies that enabled the creation of these stunning pictures. And there we have it, another fantastic episode of Astronomy Daily in the can. Thank you, Brian May. Thank you, everybody, for joining us. And if you would like to catch up with past episodes of this and also Space Nuts, the parent podcast presented by my big brother Andrew Dunkley and Professor Fred Watson, go to spacenut.io, where you can get your fill of space, science and stuff whenever you'd like it. Anything you'd like to add, Halley?
And don't forget to visit the Facebook page too. It's called the Space Nuts Podcast Group.
That's where we can all join in and show our citizen scientist stuff.
We would love to see you over there. Hey, Steve, is that smoke in the studio?
Oh yes, I'm just whipping up something on the sandwich maker. Would you like a bite? Maybe a megabyte?
I calculated a 100% chance of that joke coming.
Oh well. What if I microwave a couple of CDs for you?
Okay, maybe some humble pie or chili peppers.
Smashing Pumpkins.
Perfect.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.